Okay, hello sixth graders. So today we are looking at Chapter 2, Lesson 1, Decimals and Fractions. We are working on page 89. Our learning standard today is that we will be able to find a percent of a quantity as a rate per 100, also known as a percent. Solve problems involving finding the whole given a part and the percent. All right, so we are starting on page 89, and we just want to review our notation and how to read and write decimals and fractions and compare them. So in this example, the instruments below show the part of the students in the school orchestra that play each type of instrument. So brass is listed as 0.25, and when we read 0.25, we say 25 hundredths. So that's 25 hundredths. All right, and then that's important because that reading that the correct way is actually going to help us to be able to write that as a fraction correctly. So when we have 25 hundredths, that's just written as 25 over 100, 25 hundredths. So to write that as a fraction, we write it as 25 hundredths. Of course, we all know that that can be simplified. We know that, we learned that in elementary school, but our focus today is going from decimal to fraction. Okay, and the other way as well. Okay, percussion, we have 0.15. So how would we write that in word form? How would we read this? Okay, we would read this and write it as 15. So you look at the number 15, ignoring the decimal for a moment. And then you look at the place value. So this is the tenths place, this is the hundredths place. So it's 15 hundredths. And then if we want to write that as a fraction, writing it correctly in the word form helps us to write it correctly as a fraction, 15 hundredths. Okay, and we can check that with a calculator while we're learning. We won't be able to use a calculator while we're testing. This is something that you are expected to know very thoroughly without a calculator. But if you're ever not sure, you can simply divide it out, 25 divided by 100, because remember that fraction bar means divide. 25 hundredths is 0.25. So you did that correctly. And then second problem, 15 over 100. You can check. I mean, it's when you read it, you probably won't need to do this, but you can if you want to check that with a calculator. So there it is as a decimal, 15 hundredths. Okay. Again, we're not using the calculator to do our work, but while you're learning on the practice, you can use it to check your work to make sure that you did it correctly. Strings, we have 0.31. So again, to write that in word form, we would ignore the decimal for a moment and write down the number 31. And then we write the last digit's place value. So the 3 is in the tenths place, the 1 is in the hundredths place. So 31, this is the hundredths place. And to write that as a fraction, 31 over 100. Okay, moving on to woodwinds, 0.29. So to write that in word form, and the correct way to read that is 29, and then the 9 is in the hundredths place, so 29 hundredths. And to write that as a fraction, 29 hundredths, 29 over 100. And so when you're looking at your comparison between decimals and fractions, it should really stand out to you and be very obvious. This is red, 25 hundredths. This is red, 25 hundredths, right? 2 decimal places in the decimal, 2 zeros in the denominator. So 1 followed by 2 zeros. When we look at this number 4, 15 hundredths is how we read this. 15 hundredths is how we read this. You look at the decimal, you have 2 digits in your decimal. You look at your denominator, you have 2 zeros in your denominator. Okay, look at number 6. 31 hundredths is how we read it as a decimal. 31 hundredths is also how we read it as a fraction. You look at your decimal, 2 digits after the decimal place. Then you look at your fraction, 2 zeros in the denominator. Looking at number 7, 0.29, or it's 8 actually, 29 hundredths, 29 hundredths. We have 2 digits after the decimal, 2 zeros in the denominator, okay? And again, these are read the same way. When we read this, we read it as 29 hundredths, and also when we read this, we read it as 29 hundredths. Okay, so that's just a refresher on going from decimals to fractions. All right, let's turn to page 90. Okay, so we're going to next, we're going to learn to write decimals as fractions and mixed numbers. So remember, fractions are things that just have a numerator and a denominator. Numerator and denominator. A mixed, so this is a fraction, and it can be a proper fraction or it can be an improper fraction. Proper fraction, remember, means the numerator is smaller than the denominator. Improper fraction is the other way around. The denominator is large, or excuse me, the numerator is larger than the denominator. Mixed number is when we have a whole number or a unit and then a numerator over denominator. That's a mixed number. I know you learned that in elementary school, but I just wanted to refresh your memory. Okay, so again, fractions are written simply as numerator over denominator. Mixed number is written as a whole number and then a numerator and denominator. So you might hear you may have 2/3. That'd be a regular fraction. And a proper fraction, if you had 3 halves, that would be an improper fraction. A mixed number means we have a whole number and we also have a fraction, okay, like 1 1/2, 2 5/3. So decimals like 25 hundredths, 15 hundredths, 31 hundredths, 29 hundredths can be written as fractions with denominators of 10, 100, 1000, and so on. Any number that can be written as a fraction is called a rational number. And we just finished our whole chapter on ratios, and I want you to notice we see the word ratio right in the word rational, R-A-T-I-O. And we also see it in fraction, R-A-T-I-O, because these are all, they all have the same root word because they're all very similar. A ratio is a comparison of 2 numbers, okay? So when we can write something as a fraction, it's called rational because we can write it as a comparison between 2 numbers. So decimals like 3.25, 26.82, and 125.54, which we read as 3 and 25 hundredths, 26 and 82 hundredths, 125 and 54 hundredths can be written as a mixed number in simplest form. So example 1, okay, and if you need additional help with this, you can look in the tutorial in your online textbook. There's a video that goes along with it. So write each decimal as a fraction in simplest form. So when reading this correctly is really going to help us to be able to easily go back and forth between decimals and fractions, okay? So when we read this, we want to make sure that we say 6/10. We don't want to say 0.6. We want to get in the good habit of reading this as it's written, 6/10. Okay, so 6/10, we can write that as 6/10. We look at 6 and 10, we say, hey, they have a greatest common factor of 2. So 6 divided by 2 gives me 3. 10 divided by 2 gives me 5, 3/5. So we had that GCF of 2. So this simplifies to 3/5, okay? And then you can always check that if you're not sure, right? 6/10 is what we started with. Is that equivalent to 3/5? Yes, it is, okay? And we can check this. In this problem, it's really easy to check. We can just say, 3 doubled is 6? So 5 doubled, if 5 doubled is 10, then this is correct, which it is. 3 times 2 gives us 6. 5 times 2 gives us 10. Now, not all of your fractions are going to have such an easy way to check. Here's another way you can check to see if 2 numbers are proportional, or if you have simplified a fraction correctly, you can multiply. The cross products will be equal. Okay, again, if you have simplified your fraction correctly, which we have here, your cross products will be equal. And what I mean by cross products, so these are the diagonal. Product is the answer to a multiplication problem, so we'll multiply diagonally. 3 times 10 is 30. 6 times 5 is 30. Okay, so I just multiplied on the diagonal. Those are called cross products. So I can just check and make sure two fractions are equivalent if I can see that their cross products are equal. All right, so when this is here for reference for you. This is on page 90. If you know you're gonna forget these, you might even wanna just like cut one of these out of your book and maybe go to the back of your book and just glue that in to the back so you have that easy access to that. If you know that you don't have these memorized yet, you might want to just cut one out and paste that in the back of your book so you can always just flip to it very quickly. Okay, but here's our decimal. Okay, to the right of our decimal, we have tenths, hundredths, thousandths. Okay, and let's add on one more. If you had another one, it would be 10 thousandths. So 10 thousandths. And you would just add another 0 after the decimal there, so you'd have 3 zeros and then a 1. Okay, and these are not as hard to memorize as you think. So the first decimal, the first number after the decimal is the tenths place. And if you think of it, a 10 has 1 0. Okay, the second decimal, the second number after the decimal, excuse me, the second number after the decimal, that's the hundredths place. And if you think of the number 100, the number 100 has 2 zeros. Okay, third place is called thousandths. How many zeros are in 1,000? 3. Okay, the fourth place after the decimal is called the 10 thousandths place. How many zeros are in a 10,000? 10,000. 1, 2, 3, 4. Okay, so there is a logic. It's not like you just have to flat out memorize these. It does make sense. You can, if you forget it, you can always figure it out in just a few seconds. And then the numbers to the left obviously are the same as you have learned all through elementary. Okay, the ones place, the tenths place, the hundreds place, the thousands place. And you'll see that mirroring. So here's the 1, here's your decimal. Okay, and then the tenths is to the right of the decimal, the tens is to the left. Hundredths to the right, hundreds to the left. Thousandths to the right, thousands to the left. Okay, so that will mirror all as you continue to go left and as you continue to go right, each one will have a partner. Okay, and the 1 and the decimal are right there in the middle together. Okay, let's look at example 2. We have 0.45, but that's not how we're going to read it anymore. We're going to read that as 45 hundredths. 45 hundredths, we say that, 45 hundredths, we write it 45 over 100, 45 hundredths. Then we look for the greatest common factor. 45 and 100, they both end in a 5 or a 0, which means they are both divisible by 5. Our GCF was 5. So I can simplify that fraction by dividing them each by 5. 45 divided by 5 is 9. 100 divided by 5 is 20. So we get 9/20. Okay? And again, if you're ever not sure, you can divide that on you can do the cross products method, which I just mentioned right up here. Okay? Or you can also, if you have a calculator, while you're doing homework only, not on tests or quizzes, you are allowed to use your calculator to check that. So let's go ahead and do that. So I see 45 hundredths. If I simplified my fraction correctly, and I wrote it correctly in the first place and then simplified it correctly, 9/20 will be equal to 0.45. So when I remember 9/20 means 9 divided by 20, or 9 out of 20. So if I divide that out, 9 divided by 20, yes, I get 0.45. So I can check it that way as well, okay? I could also check it with our cross products. Okay, is 45 over 100 equivalent to 9 over 20? Well, I can multiply my cross products. What's 9 times 100? 900. What's 45 times 20? 45 times 20. 5 times 2 is 10. Write the 0, carry the 1. 2 times 4 is 8, plus the 1 we carried is 9, and then bring down this 0, 900. So yes, our cross products are equal. Right, number 3, we have 375 thousandths. This is the tenths, hundredths, thousandths place. So when we read this, we say 375 thousandths. We write it as 375 over 1,000. These are both divisible by, I think, 25. Let's see here. 125, excuse me. Yeah, 100 plus 100 plus 100 is 3. So these are both. And if you don't get that in the first place, let's say you divide them by 25, and then you can see they can be simplified again. That's okay. If you didn't find the GCF the very first time, you can continue to simplify until they're all the way simplified. So a GCF here is 125. 125 goes into 375 3 times, and then goes into 1,000 8 times. But again, let's say that you only realized the 25. So if you did 375 divided by 25, you would have gotten 15. And then if you did 1,000 divided by 25, you would have gotten 40. And then you would have looked at the 15/40ths and said, oh, I can simplify that further. 15 and 40 are both divisible by 5. I get 3/8, 3/8. Okay, let's do a few more practice problems. We're at the bottom of page 90. Got it, A, B, and C. So when I read this number, I read it as 8/10. So I write it as 8/10. I look at 8/10. I want to see if I can simplify that further, which I can. And 8 and 10 have a greatest common factor of 2. 8 divided by 2 is 4. 10 divided by 2 is 5. So my simplified fraction is 4/5. Okay, then I look at 28/100 is how I read it. So I write it as 28/100. These have a GCF of 4. Yep, a GCF of 4. So 28 divided by 4 is going to give us 7. 100 divided by 4 is going to give us 25. So we get 7/25. And then here we have 125, and then this is the thousandths place. So when we write this, we're going to write it as 125 thousandths. Okay, and then these numbers are both divisible by 125. Okay, 125 goes into 125 one time. 125 goes into 1,000 8 times. Okay, and if you think of, half of 1,000 is 500, half of that is 250, half of that is 125. So you can think of it just breaking it down. An eighth of 1,000 is 125. So the GCF here was 125. Okay. And if you can't do that with mental math, that's okay. You can just divide out. You can see they're both divisible by 25, because 25 will always go evenly into anything that ends with a 00. Think of 25 cents will always go into any dollar amount. Okay, so you can divide each of those by 25, and then you would get an intermediate fraction, which you could simplify to 1/8. Okay, but the GCF was 125. All right, example 4 at the top of page 90. Okay, so the average length of a conch shell is 9 8/85 of an inch. Express 9 8/85 as a mixed number in simplest form. Okay, so when we read it, it's 9 8/85 as a decimal. When we write it as a fraction, 9 85 over 100. So let's see, 85 and 100, let's leave the whole number is going to be the same. So there's our 9. So when we think of our 85, we want to divide that by 5, we get 17. 85 divided by 5 will give us 17. So here's our 85, divide by 5. How many times does 5 go into 8? Once. 5 times 1 is 5. Subtract. 8 minus 5 is 3. Bring down the 5. How many times does 5 go into 35? 7. Okay, so if I divide this by 5, I get 17, and then 100 divided by 5 gives us that 20. Okay, so 9 17/20. All right, let's do got it D. I'm going to zoom out a little bit. It takes approximately 4 65/100 of a quart of milk to make a pound of cheese. Express this amount as a mixed number in simplest form. Okay, so not 4 65/100. So actually work right. Well, if I work over there, I have to zoom out. So let's just work right here. 4 65/100. So I know I'm going to leave my whole number alone, my 4. Okay, I look at 65 and 100. They both are divisible by 5. I know that because the divisibility rule for 5 is if the number ends in a 5 or a 0, it's divisible by 5. Okay, so then I divide that out. 65 divided by 5. 5 goes into 6 once. That's a 1. 1 times 5 is 5. Subtract. 6 minus 5 is 1. Bring down the 5 is 15. 5 goes into 15 3 times. And then we have no remainder there. So that's 65 divided by 5 gives us 13. And then 100 divided by 5 gives us 20. So 4 and 13/20ths when we write that as a mixed number. All right, now our next, so that was the first part. We were writing in decimals and writing decimals as fractions and mixed numbers. Okay, so now we're going to go the other way around. Okay, we're going to go backwards, and we're going to write fractions and mixed numbers, and we're going to change those into decimals. So this is just the reverse, okay? So it's just looking at it the other way around. That's all it is. This is just part 2. For fractions with denominators that are factors of 10, 100, or 1,000, you can easily write the equivalent fractions with those types of denominators. So when I have 9/12ths. So 12 is not a factor of 10. So that's not going to work out really easily for us. So what we want to do is see, can we scale it up or down to make it into a multiple of 10? Okay, so I can't easily scale it up. If I multiply it by 10, I'm going to get 120. That's not a 10 or a 100 or a 1,000. But when I look at the number, I notice that those numbers are both divisible by 3. And so I'm going to scale it down and see if that helps me at all. 9 divided by 3 is 3. 12 divided by 3 is 4. So 3/4 can go evenly into 100, okay? So 4 can go into 100 if I multiply it by 25. So if I take my 3, I have to do this same thing. Whatever I do to my denominator, 4 times 25 is 100. I have to do to my numerator. 3 times 25 is 75. So I can write that as 75 over 100. Now that is a factor of 10. My denominator is a factor of 10, excuse me. So I want my denominator to be a factor of 10. Okay, so now I read it, 75/100ths, I write it 75/100ths, okay? So sometimes you will need to scale down and then scale up. So I scaled from 9/12ths down to 3/4, simplified the fraction, and then I saw that I can go into 4 into 100. Okay, so this is all without a calculator. We're brushing up on our mental math skills and our arithmetic skills, doing these without a calculator. Okay, the second method is use long division. Okay, so 9/12ths, 9 divided by 12, and we can see the long division. Does 12 go into 9? No. So above the 9, I write a 0, and I bring my decimal straight up. Bring the decimal straight up. Does 12 go into 90? Yes, 7 times. Okay, 7 times 12 is 84, and then we subtract. 90 minus 84 is 6. Bring down the 0, and I get 60. 12 goes into 60 5 times. 5 times 12 is 60, 0 remainder. So then I get 0.75, 75/100ths. So that's the second method, okay? So method 1, if you can play with the numbers to avoid having to do long division, you can work it to see if you can get into factors of 10, so 10, 100, 1,000, 10,000, etc. And then method 2 is just divide them out. Remember, this means 9 divided by 12. Okay, let's do got it, E, F, and G. Okay, 3/5. When I look at 3/5, I see my denominator of 5, and yes, that can very easily, I can see it's going to go into 10. So I scale it up to 10. 5 times 2 is 10. Whatever I did to my denominator, I have to do to my numerator. 3 times 2. 3 times 2 is 6. So I get 6/10, and I can write that as a decimal. 6/10. All right, 14/25. Okay, can I scale this up? Yeah, to any factors of 10 or down. I can't scale it down to 10 because 25 there's nothing I can multiply 10 by to get to 25. So I try to scale it up to 100. Yes. 25 times 4 gives me 100. So then I multiply whatever I do to the denominator, I have to do to the numerator. So I do 14 times 4. 4 times 4 is 16. Write the 6, carry the 1. 4 times 1 is 4 plus 1 is 5. So 56 hundredths, and then I can write that as a decimal, 56 hundredths. Okay, and then the last one we have is 102 250ths, 102 250ths, and then I know 250, I think of 25 going to 100 is proportional to 25 going into 1,000. Okay, so how many times does 25 go into 100? 4, add a 0, add a 0. Now it's not 25 and 100 anymore, it's 250 and 1,000, okay? So, but it's proportional. How many times does 250 go into 1,000? 4. Okay, so I did times 4 to get to 1,000. So whatever I do to my denominator, I have to do to my numerator, times 4. And I don't have to carry or anything, so I can just multiply. 4 times 2 is 8. 4 times 0 is 0. 4 times 1 is 4. So 408 thousandths. So we would write that as 0.408. 408 thousandths is our answer. Okay, so that was chapter 2, lesson 1. Okay, pages 89 through 91, writing decimals as fractions and writing fractions as decimals.